나는 역전을 위해.
나는 다시 빛나기 위해.
나는 빚을 갚기 위해서.
나는 개가 되기 싫어서.
나는 역전을 위해.
나는 다시 빛나기 위해.
우린 스타트업한다. 스타트업 10월 첫 방송.
안녕하세요. 저는 한나이 가락 가수입니다.
안녕하세요. 저는 아들 여시구스입니다.
And we are your Earth Science presenter today's lesson. Stay with us as you learn through this objective. Describe how rocks behave under different types of stress such as compression, pulling apart, and shearing. Knowing that rocks are continually subjected to forces and tend to bend, twist, or fracture them, how do rocks behave under different types of stress? This is the question that will guide us in today's lesson to describe compression, pulling apart, and shearing on rocks. Are you ready? I'm carried away. By the way, going back, if you're ready, then we'll start up with considering what can happen to rocks when they are exposed to stress.
In geology, stress refers to the force per unit area on a rock. When stress causes a material to change shape, it has undergone deformation or strain. A rock's response to stress depends on various reasons, such as the type of rock, the surrounding temperature, and the pressure conditions.
These stresses sculpt the face of the Earth by creating new landforms and restyling the outlines of continents, since these stresses relate tectonic plates that lie underneath all of the world's lands, masses, and oceans. The three main types of stresses that affect the Earth and correlate with the three types of tectonic plate boundaries are stress in school works, stress in life, stress in hospice, stress po sa report na to, stress po kay Al.
What type of stress? We're talking about rocks.
Sorry. So guys, going back to our topic, here are the three main types of stress: compressional stress, tensional stress, and shear stress.
Compressional stress squeezes rocks together. It happens at convergent plate boundaries in which two tectonic plates are pulling each other. Powerful earthquakes tend to strike areas in which compressional stress is at work, such as in Chile where the Nazca and South American plates are smashing into each other.
Opposite to compressional is tensional stress, or sometimes known as extensional stress. Tensional stress stretches and pulls rock apart and occurs along divergent plate boundaries where two tectonic plates are tearing away from one another. An example of this is the Mid-Atlantic Ridge, where the plates occurring North and South America are moving west, while the plates occurring in Africa and Eurasia are moving east.
Finally, shear. The term shear refers to the motion of two rock surfaces rubbing against each other. As the rocks slide against one another, the third sort of stress causes them to change shape. Shear stress is the most prevalent stress seen in transformed plate boundaries, and it appears to occur near the edges of the conflict. However, it may also occur in other places. It usually takes place between 10 and 20 kilometers beneath the surface of the Earth. Fracturing and faulting would happen if the same process occurred at the surface. When forces glide past each other, shear stress occurs. A well-known example of this is the strike slip fault San Andreas in California. As we know, sedimentary rocks are formed with oldest layers at the bottom and the youngest at the top. Sediments are usually deposited horizontally. That is why sedimentary rock layers are originally horizontal, and those that are not horizontal are considered deformed.
The deformation that a rock has experienced is actually traceable using its horizontality. This deformation is what produces geologic structures as faults and folds. We all experience stress, right? Well, rocks are not an exception because they do as well. When rocks experience compressive stress and deform plastically, they crumple into folds. It causes the rocks to bend and never return to their original shape.
It's like how your ex never returned to you.
No, it's like the shoe after I throw it to your face.
Sorry about that. But anyway, there are three types of folds. Firstly, monocline. A monocline is a simple bend in the rock layers, having the oldest rocks at the bottom and the youngest at the top. Here we have the Grand View Phantom monocline located at Grand Canyon, Arizona as an example. We can see that there is a bend or slight curve on the rock layers compared to the horizontal layers visible in the surroundings.
Next, we have anticline. An anticline is a fold that arches upward. And unlike monocline, the oldest rocks are located at the center of an anticline, and the youngest are draped over them. We have this as an example. It is an anticline located near Eden, Lebanon. We can see that the layers are arching upwards instead of the usual horizontal.
Lastly, syncline. Syncline is a fold that bends downwards, and rocks are curved down to the center. The youngest rocks are at the center, and the oldest are at the surface of the fold. Here is a beautiful example of a syncline fold exposing sideway volcano. We can see that the rock layers are bending downwards, forming a wide like line. To sum it all up, folds are formed when rocks experience compressive stress and then deform plastically. There are three types of folds: monocline, or the simple bending in the rock layers; anticline, or the upward arching of rock layers; and lastly, syncline, or the downward bending of rocks.
Just like what we've said earlier, rocks undergo stress too. But when rocks undergo too much stress, they tend to fracture. The fracture is called a joint when there is no movement on either side. However, if the blocks of rock on one or both sides of a fracture move, the fracture is called a fault. Sudden motions along faults cause rocks to break and move suddenly, and the energy released is what we know as earthquakes.
Faults can be classified into three types, namely normal, reverse, and strike slip. Normal faults are the most common faults, often found along divergent boundaries. It forms when the hanging wall or the bottom of the fault drops down relative to the footwall or the top of the fault.
On the other hand, reverse faults are formed when the footwall drops down relative to the hanging wall. It is most common at the convergent boundaries. They are responsible for uplifting mountain ranges in regions experiencing compressional stress.
Finally, we have strike slip faults. It forms when the walls move sideways instead of up or down. Strike slip faults result from shear stresses. Most common are transformed fluid boundaries.
To summarize, faults are when fractures on Earth's crust move. It has three types: normal fault, or when the hanging wall drops down; reverse fault, or when the hanging wall is pushed up; and strike slip fault, or when rocks' walls move sideways. And that concludes our presentation. 다시 제 이름은 한나리입니다.
그리고 나는 아들이 저스틴입니다.
들어주셔서 감사합니다.
빠진 것처럼 사랑하자 딱 하나만 아는 잘못된 것처럼 Love